In this video, we are going to learn about hydrates. And hydrates are basically ionic compounds with water molecules. Here I have a chemical formula of a hydrate. In this case, is magnesium chloride hexahydrate. Think of the term hydrate. When you are hydrated, you have plenty of water. So if you have a hydrate, it has water molecules in it. Now the opposite of hydrate is anhydrate. An is without. So without hydrate would be without water. Now let's look at the chemical formula more closely. First of all, you notice that there is a dot right there. That dot, if you go back to your math class and you realize, hey, this dot is actually representing a multiplication sign. So basically saying that there are 6 water molecules surrounding this ionic compound. So the whole entire thing is called a hydrate. But if we look at the ionic compound, that is called the anhydrate. Because the water molecules are not bonded directly to the ionic compound, we can actually adding a lot of heat and this water molecule will evaporate, leaving us this anhydrate. So our goal for today is to find the chemical formula of a hydrate. There are steps to find the formula for the hydrate. The first steps is, of course, we notice there are 2 parts, the water and the anhydrate. And that is, the first step is to find the moles of the ionic compound and the water. From the given information, in most cases, it will give you in terms of percent, or in the other case, it will give you in terms of the masses of the water molecules, as well as the ionic compound. And once we get a mass, it's very easy to convert to mole. Basically, we take the mass times the molar mass conversion factor. And once we get a mole, we make a ratios in terms of mole by dividing by the lowest number of mole. And that gives us a whole number of water molecules relative to the smallest number of moles, which is usually the ionic compound. So let's do an example problem together. And if you notice, this is very similar to finding the empirical formula. It's just now that we are looking for molecules within a larger compound. In this case, this hydrate here has 2 different molecules in it. And we are looking for the ratio in terms of mole. So let's go back and try one problem together. A hydrate has 45.4% water, 54.6% cobalt chloride. In this case, what is the chemical formula of the hydrate? Well, first of all, we have percentage. And we know that percentage is out of 100. So when we have percentage, we can assume that this sample theoretically is out of 100 grams. By doing that, we can change that to gram automatically. So let's look at this work. For water, I have 45.4%. And by assuming it's 100, I have 45.4 grams of H2O. And of course, I can convert it to mole easily by multiplying to the conversion factor of molar mass. And notice the mass is on the bottom, so the gram cancel out, give us 2.519 moles of water. We are going to do the same thing to the cobalt chloride. In this case, we have 54.6%. That will become 54.6 grams of cobalt chloride because we assume it is out of 100. And again, multiplied by the molar mass conversion factor, the grams go on the bottom, give us 0.4205. And of course, this is the lower number or the lowest, so we divide both moles by this number. And of course, this gives us 1, that's easy. And over here, we would have divided by 0.4205. And if we plug this into our calculator, we have 5.99. And of course, we can round this to 6. So what does that tell you about the chemical formula? That tells you there are 6 H2O and 1 mole of cobalt chloride. So our chemical formula for the hydrate would be COCl2 dot, basically time 6 molecules of water right there. Now let's try a more challenging problem. In this case, in an experiment, a student is assigned the task of determining the number of moles of water in 1 mole of magnesium chloride. So we have N of water molecules right there. This is supposed to be lowercase subscript right there. And the student collected data shown in the following table. So the experiment is done already. Now we need to analyze the data given to us. So let's look at the data. First of all, we have an empty container, which is the tray that we contain the hydrate in. And we get the mass for it. And then we get the initial mass of the sample and the container, which is the hydrate and the tray, okay? Then we have the mass of the sample and the container after the first heating. So we heat it and then we weight the container with the mass of the hydrate. But notice how the mass decreased, right? And then from 5 to 4, that tells you that the water has been driven off. It has evaporated. And we do that again for the second heating, and notice again the mass has decreased because more water is now driven off. It has evaporated away. Then we did the third heating, and notice how there is very little changes, 0.01 changes. That tells you all the water has been evaporated. Now you have only the anhydrate. So let's go back and label this. We call this container, let's call this the tray. And then we have the mass of the sample and the container, which in this case we have the hydrate. We call this hydrate plus the tray. Let's abbreviate with T. And then we have the mass of sample after the first heating, and then second heating, and then third heating. The most important one is the third heating, because we want to get the data where we only want the anhydrate, because we are going to take this information to determine how much mass of water is driven off. Now let's visualize our data. First of all, if we notice how I draw it out, the red part represents the water in the hydrate. So we notice all the data has the tray in it. So this particular student did not zero out the mass of the tray. So when we try to solve for, of course, we need to solve two things. One is going to be, oh, this one is supposed to be calcium chloride. My bad. So first of all, there are two things that we need to solve from this data. One is the moles of water, and the other one is the moles of the anhydrate. In this case, it's calcium chloride. This is a mistake, okay? So calcium chloride. So what we have here is this. We have the red line represent the water, and how the water get removed over time. So in order to solve for this water, of course we're going to have to use the one with the water in it. And then we want to find the difference that's represented by the red marker, which is the very last heating, because all the water has escaped. So we're going to use that two values, and basically using our algebra, we know that this right here represents the hydrate, which is right there, plus the tray of the container. So all we have to do is minus the tray and minus the anhydrate, which is the ionic compound, and give us a water. So we can actually substitute in the values. Notice this is coming from here, right there. So that is our tray plus the hydrate, minus the anhydrate with the tray, which is this one right here, give us our mass of water, 1.18 grams of H2O. And once we get our mass of water, of course we can convert directly to mole. And that is very easy. But before that, let's find the mass of the anhydrate. That's a little bit tricky. First of all, we need to look at the picture again. I need to find the one that has the anhydrate by itself. Okay, that's right there, and that's right there as well. But we don't care about the second heating. We care about the last heating because all the water has been driven out. So of course we're going to use this one for sure. Now the second part is that this one has the anhydrate and the tray. So we need to remove the tray, but look right there. We have the mass of the tray. So all we have to do is take this number, tray plus anhydrate, minus the mass of the tray, give us 3.54 grams of calcium chloride. And that would be our mass of the anhydrate. And of course now we have the mass. What's the next step going to be? The next step is to define the mole. And that is pretty easy. I just multiply for water by the molar mass, which in this case 18.02 grams of H2O will be on the bottom. And this will be 1 mole of H2O. And when we plug this into our calculator, we have 0.0548. And then we do the same thing for this one as well. The only tricky part is that we have to find the molar mass of calcium chloride, which turned out to be 110.98 grams of calcium chloride, CO2, and that is 1 mole of calcium chloride, CO2. That cancel out and give us 0.03189. And this is the lower number, so we divide both of them by this number to get our ratio. In this case, 0.3189. Same thing in this case as well. And if we plug this into a calculator, we have about 2.05, which we can round it up to 2. And of course, this one just cancel and go to 1. So what does that tell you? That tells you that this compound, or this hydrate, has 1 mole of CaCO2 and times by 2 mole of H2O. And that is all we have to do to find the chemical formula of a hydrate.